Take a look at the sky at night. Do you see from Earth the same rainbow-colored pictures that astronauts show us? I personally do not. And of course, I was once interested in the question of such a colorful universe. How is this possible? If you're also interested in the question of the multicolored universe, put in a virtual spacesuit, sit back, do not forget to subscribe to the channel if you are not subscribed yet, and get ready for an exciting flight to the end of this video. Because after watching to the end, you will learn the whole truth about the real colors of space and why do astronomers fool our brains. What is the real color of space? The universe is breathtakingly beautiful. Over the past decades, thanks to telescopes such as Hubble, we have been able to see the cosmos in a colorful way, as if immersing us in a magical world. It was as if an artist had waved a rainbow brush across the black canvas of the abyss. However, what we see in color photographs of the universe is a fake created for our convenience, comfort, and attention. But why did astronomers conspire to plunge us into the turmoil of colorful dreams? Let's try to understand this conspiracy from the very beginning, from the basics of what color is, how photographs of space are created, and why does NASA still color them. Have you looked through a telescope at least once in your life? If so, then you should be well aware that the eye does not see even a tenth of the same color range that researchers show us in photos and videos from space. The most that an observer using a modest amateur instrument can count on is to distinguish the colors of planets and bright stars. If we talk about the colors of the nebulae, then, alas, this is a very difficult task even for the eye, armed with even a large telescope. But why can't we see such colorful objects through a telescope? The answer to this question lies in the peculiarities of human vision. The fact is that there are two types of light-sensitive receptors in the eye. Stars in galaxies emit waves of electromagnetic radiation which can be divided into different groups depending on the wavelength of the emitted waves. These groups include gamma rays, X-rays, ultraviolet light, visible light, infrared radiation, microwaves, and radio waves. Visible light makes up a tiny part of the electromagnetic spectrum in terms of wavelength range, but it's the only region that the human eye can see. What we perceive as colors are really just different wavelengths of visible light. Reds and oranges are longer, while blues and purples are shorter. The visible spectrum of a star or galaxy is a measure of the brightness and wavelength distribution of light that a star or galaxy emits, which in turn can be used to determine the average color of a star or galaxy. In 2002, during the largest galaxy research program ever, scientists captured the visible spectra of more than 200,000 galaxies from across the entire observable universe. By combining the spectra of all these galaxies, astrophysicists were able to create a spectrum of visible light that accurately represented the entire universe. Thanks to the introduction of color and also composite photography through various color filters, celestial objects were immediately painted with all the colors of the rainbow. After all, the film perceives color even in low light, so even foggy objects show their colors well on it. Analysis of the cosmic spectrum in turn allowed scientists to determine the average color of the universe. The researchers used a color-matching computer program to convert the cosmic spectrum into a single color visible to humans. The team determined that the average color of the universe is a beige shade, not too different from white. Although this is a rather boring discovery, it is not surprising given that white light is the result of the combination of all the different wavelengths of visible light, and the cosmic spectrum includes a very wide range of wavelengths. The Hubble Space Telescope has been orbiting Earth since the 1990s, allowing us to peer into the far corners of the universe and present images like this. The trick is that every color frame starts life in black and white. This is due to the fact that the main function of a telescope is to measure the brightness of light reflected by objects in space. Most clearly, such frames are obtained in black and white. Colors are added later, much like the black and white photographs we send in for restoration, except that the scientists use specific programs like Photoshop. Space program filters separate light into long, medium, and short wavelengths. The process is called broadband filtering. because it targets wide ranges of the spectrum. After that, each black and white frame gets its own color depending on the position in the visible spectrum. The combined result allows us to see the true image if our eyes were comparable to Hubble in power. So, are you ready for the next level? Seeing an object as it appears to our eyes is not the only way to apply color. Scientists use color to determine how different gases interact in space to form galaxies and nebulae. For example, the Hubble Space Telescope is only capable of taking pictures of very narrow spectra of light coming from individual chemical elements such as oxygen and carbon. Color allows you to identify their presence in the images. This process is called narrowband filtering. The most common application of such filtering relies on the isolated light of hydrogen, sulfur, and oxygen, the three building blocks of stars. The most famous example of a photograph taken using narrowband filtering by Hubble is Pillars of Creation. The frame shows incredibly huge columns of gas and dust in the process of forming new star systems. Incredible footage. Pictures in different ranges are light-coded based on chromatic order. Low frequencies turn red, high frequencies turn blue. Such manipulations of our perception may raise the question, is color really real? Yes and no. Color reflects real data and is used to visualize the chemical composition of an object or region of space, helping scientists figure out how gases thousands of light years away interact with each other. This is critical information thanks to which we can build models of the formation of galaxies and stars. Even if space does not look so colorful to us from the technical side, the results of observations and surveys are still real. How do you like this rainbow journey? Now you can unfasten your belts and subscribe to my channel to keep abreast of events from the world of science and space. Hug everyone!